picture of this kid swinging like this at the extremes in the bottom, does it make sense that this extreme and this extreme are the same?
Yes.
So I'm not going to have to worry about that. So if I do a force diagram here, we have Ft and we have Fg. Does that make sense? Now, do you see that this Fg does two things? It pulls down and it goes sideways. Do you see the perpendicular one has nothing to do with the tension? So this is mg cos theta. Now, what is the velocity of that kid at the extreme? 0, right? So, and this kid's kind of moving in a circle, isn't he? So what is the sum of the forces on this kid? Yeah, mv squared over r. So we're going to get mv squared over r. But we just said the kid was moving how fast? 0. So at the extremes, the tension is just mg cos theta. Sure. Well, let's just go ahead and write. Does it make sense to you that it's going to be Ft minus Fg, right? And this is for part A. Oh, I'm sorry. This is for part B. Excuse me. Let me do this. Let me correct that. If I'm going to do this for part B, do you see that this is Ft minus mg cos theta? Does everybody see that? But what is the velocity of the kid? 0. So that goes away. So I get Ft equals mg cos theta.
Is this at the extremes?
Yep, this is the extremes. Now, when we do it in green, at the bottom, we get Ft minus mg equals mv squared over r. Now, if the kid's swinging and they make an angle of 40 degrees, how do we find the velocity at the bottom? Remember, this is our friend. No? I guess you don't remember our friend. You've hurt our friend's feelings. It's the square root of 2gl times 1 minus cosine theta. Okay, so that means Ft minus mg is equal to m times 2gl times 1 minus cosine theta over r. So then, do you see where that brings us? That brings us, because then this we can move over, so the force of tension is just going to be 2mgl times 1 minus cosine theta over r plus mg. You guys okay? Does this work? Questions? So then once again, we can call upon our crapulator. And we say 2 times 9.8. Oh, just kidding. What was the mass of this kid? 20. Good. I'm glad they told us that. 2 times 20 times 9.8 times 3.5, open parentheses, 1 minus cosine of 40, all divided by 3.5 plus 20 times 9.8. Enter. And we get 287 newtons.
Where's the radius? Just 3.5.
Yeah, the radius is just 3.5. Did I just say 287 or 387? 287. And this is 200 times the cosine of 40, which I don't remember. What does this one come out to be? Or 198 times cosine of 40 or whatever. 20 times 9.8 times cosine 40. You know, you really should be doing the calculations like in class. Even if you don't write this down, you should do the calculations so you can make sure that you know how to do it when you take the test. What? 150? Big difference. It almost doubles at the bottom.